Alright, today we're going to be looking at elimination. The first example we have is the system of linear equations. We've got 3x minus 7y equals 10 and 6x minus 8y equals 8. The first thing we want to do is multiply one or both equations so one variable has the same coefficient but different sign. So the keys here is either one of them or both of them. We want them to have the same coefficient, so the same number in front, but a different sign. So if we come up here and look, we've got 3x and 6x. We also have negative 7y and negative 8y. Just by looking at that, we can see it's probably going to be easier to make my x's have the same number because I can multiply this top equation by a 2, which would give me the 6, but we want them to have different signs, so we're going to multiply the top equation by negative 2. When I multiply it by negative 2, that top equation becomes negative 6x plus 14y, because negative 7 times negative 2 is positive 14, equals negative 20. The biggest thing is to not forget to multiply everything by that negative 2. All three terms have to be multiplied by it. You always want to just rewrite your second equation if we don't have to multiply. This situation we didn't have to multiply it, so we're just going to rewrite it. We want them to line up and look nice and neat. The second thing we're going to do is add the equations together. The reason we multiplied so that way one is positive, one is negative, is so that way when we add, one of my variables is eliminated. So if you notice, if I add negative 6x plus 6x, that gives me 0. So then we're going to add 14y and negative 8y, which gives me 6y, and add negative 20 plus 8, which gives me negative 12. Now we solve for y, and we get y to equal negative 2. So now we have our y value. The next thing we want to do is plug my answer into the original equation and solve for the other variable. So we're going to take my answer of y being negative 2. We're going to plug it into my original equation. It doesn't matter which one, just choose one. So we've got 3x minus 7 times negative 2 equals 10 because negative 2 is my y value. We're going to simplify that, so 3x plus 14 equals 10. Subtract the 14 from both sides. We have 3x equals negative 4. Divide by 3, and x is equal to negative 4/3. On these problems, you always want to check your answer. It is very important you check your answer. That way you can be sure that you got it right, and you can go back and change anything. So if you plug 3 into the first original equation, you have 3 times negative 4/3, which is negative 4, minus 7 times negative 2, which is positive 14. So negative 4 plus 14 is 10. We've solved that problem correctly, or that it works in that first equation. Go to the second equation. We've got 6 times negative 4/3, which is negative 8, and then negative 8 times negative 2 is positive 16. So negative 8 plus 16 is positive 8. It works in both equations. Therefore, we have solved the system correctly, and the solution to our system is the coordinate point negative 4/3, negative 2. We always list it x, comma, y. So now if we look at a second equation, here we have 3x minus 6y equals 9, and negative 4x plus 7y equals negative 16. Here we've got 3x and negative 4x. If we think about what to multiply them by, the least common multiple between those two would be 12, so we can multiply them to get 12. 6 and 7, the least common multiple we could get with those is 42, so we'd have to multiply each equation by either 6 or 7 to get to 42. It doesn't matter which one you choose. You can either go to eliminate the x's or eliminate the y's. Doesn't matter either way. I'm going to eliminate the x's because then my numbers stay smaller. I'm only multiplying by 3 and 4. So my top equation I'm going to multiply by 4. 4 times 3x will give me 12x. The bottom equation I'm going to multiply by positive 3 because if I do negative 4 times positive 3, that gives me a negative 12. So my x's will be positive 12. My y's will be negative 12. So both of these are positive numbers because we already had one positive, one negative. So we're going to multiply all three terms. So on the top we'll have 12x minus 24y equals 36. On the bottom we'll have negative 12x plus 21y equals negative 48. Again, we add those equations together. When we do that, my 12x and negative 12x add together to be 0. They eliminate. You've got to make sure you're consciously adding, making sure they're different signs. When we add negative 24y and 21y, we get negative 3y equals negative 12. Solve for y, divide by negative 3, so we get y to be positive 4. Plug that positive 4 back into my original equation. Again, I just plugged it into the top equation. So we plug in the 4 for y. We solved for y, so we're plugging it into y. When you simplify this, you get 3x minus 24 equals 9. Add the 24, we get 3x equals 33, and we get x to equal 11. Again, you want to check your solution. So 3 times 11 is 33, minus 24 is 9. Here we have negative 44 plus 28 is equal to negative 16. It works in both of my equations, so we're going to write it as a coordinate point and box in our solution.